In this lesson, we're going to learn about finding the roots of a polynomial. What the roots of a polynomial are is it's the solution of a polynomial equation in which one side of the equation is factored and the other side is set equal to 0. So if you think about equations where if you're multiplying two things and it equals 0, then, so for example, if A times B equals 0, then either A is equal to 0 or B is equal to 0, because anything multiplied by 0 equals 0. So for example, if I had 4b or 4x equals 0, that means x would have to equal 0 because 4 times 0 equals 0. If I had negative 3y equals 0, then that means y has to equal 0 because negative 3 times 0 equals 0. If it's a times 8 equals 0, then that means a is equal to 0 because 0 times 8 equals 0. And the same thing works with binomials. If this chunk times this chunk equals 0, then either this piece equals 0 or this piece equals 0. So we can follow that same pattern and work that problem out by setting each binomial equal to 0 and solving to find what x would be. These values for x are what we would call the roots of the polynomial. So if it's something times something equals 0, either this chunk equals 0 when I solve for x, or this chunk equals 0 when I solve for x. So we have to solve both smaller equations. So in order to get x by itself, I'm going to subtract 2 on both sides, and I get x to equal a negative 2. Or on this side, I would have to add 5 on both sides to get x by itself, and I get x to equal a positive 5. These two values for x are the roots. These are what we would solve our equation for. These are the two values that we could have for x that are going to make this equation true. So both of these are correct answers. We'd say x is negative 2 and x could be 5. So when you're trying to find those roots of a polynomial, make sure, number one, that your polynomial is set equal to 0. You have to make sure that this part is set equal to 0 before you do any solving. Once it is set equal to 0, then you're going to factor the polynomial. This example here is already factored. We have our two binomials. But if it's a trinomial or it's showing difference of squares, you want to factor it so that it looks like this. It has two binomials. And then you set the two equal to 0 and solve each for x. So these are the different ways we've learned to factor using difference of squares. So for example, if it's x squared minus 16, I'm subtracting two perfect squares. This one would factor to be x plus 4 and x minus 4. When it was factoring perfect squares, these ones looked like a binomial squared when factored. It's the same binomial. Or we could use the FOIL method backwards, where you're trying to find the two numbers that multiply to get the last term, but add to get the middle term. Once you have it factored to your two binomials, then you solve each factored binomial. And that's known as either finding the zeros of a function or the roots of a polynomial. So if we looked at a few examples, again, make sure, number one, check that it's set equal to 0. This one is, so I can right away start factoring this. It doesn't show difference of squares, and it's not perfect squares factoring pattern, so we can factor it to our two binomials set equal to 0. So I know in order to get x squared, this would have to be x, and this would have to be x, because x times x is what gets me x squared. So now I have to think, what do I multiply? What two numbers do I multiply to get negative 12? That would add equal a 1 here. So if I list the factors, since it's a negative, I could have a negative 3 and a negative 4. I could have a negative 4 and a negative 3. I could have negative 2 and 6, or I could have a positive 2 and 6. But then they have to add to equal 1. So if I add negative 3 plus 4, those two add to equal 1. So this is the one we want, because this one would add to equal a negative 1. This one would add to equal 4. oops, this should be a negative here. 2 plus a negative 6 would equal negative 4. So these are the two factors we want. So these have to be x minus 3 and x plus 4. These are the two factors, but now I have to find the zeros of the function. So I would have x minus 3 equals 0, or I would have x plus 4 equals 0. Notice I just took each of those binomials and set them equal to 0. Now I solve. If I want to get x by itself, the opposite of subtracting 3 is to add 3. So I get x equal to 3. And then opposite of adding 4 would be to subtract 4. So the other option for x is that x equals a negative 4. So these are the two roots, and it's both answers. So just make sure that you're solving both binomials because they're not always going to be opposites. So just make sure you solve both. In this example, this one, it's not a trinomial, so I'm not going to factor it right away to two binomials, but I can see that this part here, this is a perfect square, and this is a perfect square, and they're separated by subtraction. So this one is actually, we could solve by difference of squares. So for a difference of squares, you have your two binomials, and we're still going to set it equal to 0. One's going to be addition, and one's going to be subtraction. And to figure out what goes inside these, we take the square root of the two terms. So the square root of 4x squared is 2x. The square root of 25 is 5. So one binomial is 2x plus 5. The other one then would be 2x minus 5. Once you have it factored, then set each of them equal to 0 and just make sure you solve both. So one root is 2x plus 5 equals 0. The other root would be 2x minus 5 equals 0. And then you solve each equation. So since it's plus 5, to cancel this out, we would subtract 5. So now I have 2x equals a negative 5. And then divide by 2. We get x to equal either a negative 5/2, or you could divide it out to be a decimal. Negative 5 divided by 2, this would also equal a negative 2.5. So this is one option for x. Same thing over here, solving. If I add 5 on both sides, now I have 2x equals 5, and then divide by 2 on both sides. I get x to either equal 5/2 or a positive 2.5. So I still have two answers for x here. Notice in this next example, this is not set equal to 0. So we have to first make sure that our equation is set equal to 0 before we factor anything. And since I want this side to be 0, I would have to subtract off 36 from both sides so that my new equation is x squared minus 5x minus 36 equals 0. Now I have a trinomial. I want to see what these two binomials are going to be. So x times x is how I get x squared, so they're both going to start with x. And now for this term, I have to figure out what do I multiply to get a negative 36 that adds to equal a negative 35. So multiplies to be a negative 36 and adds to be a negative 5. So to get to 36, I could do 6 and negative 6, but if I add those two, it equals 0. I could do negative 9 and 4, and negative 9 plus 4 equals a negative 5. That's the one we want, because negative 9 times 4 equals this negative 36, and negative 9 times, or plus 4 equals a negative 5. So my two binomials, it's going to be x minus 9 or x plus 4. So then you can solve your two equations. One is x minus 9 equals 0. The other is x plus 4 equals 0. So if I add 9 on both sides, one answer is x is equal to a positive 9. The other one, if I subtract 4, x is equal to a negative 4. So if we take a look at this one, I have x squared minus 8 equals 7x. Again, this one is not solved to equal 0, so I have to get this side to equal 0. And to do that, I would subtract 7x from both sides, making my new equation x squared minus 7x minus 8 equals 0. So I'm subtracting 7x, and the 8 was already subtracted. So now we can factor this to two binomials. So to get x squared again, it's x times x. And to multiply to get negative 8. So I want it to multiply to equal negative 8 and add to equal negative 7. So I could have a negative 2 and 4. Negative 2 times 4 is negative 8. Negative 2 plus 4 is a positive 2, so that's not right. Even if I did the other combination, 2 and negative 4, it's not going to add. So if we did negative 8 and 1, negative 8 times 1 is negative 8. Negative 8 plus 1 is a negative 7. So this is the one we want. So we would have x minus 8 and x plus 1. Then you set both of them equal to 0 and solve. So I want x by itself, so I'm going to add 8 on both sides and get x to equal 8 for this one. Subtract 1 over here to get x by itself, we get x to equal a negative 1. So these are the two roots for this equation. Now the last part of the lesson is talking about zeros of a function. This is really the exact same thing as finding the roots. It's just, notice it starts off with a function notation, f of x. You just replace, because we want to know when f of x equals 0. So you replace f of x with 0 and solve the rest of it the exact same way. So you'd set up your two binomials. To get x squared, you'd have x and x. And then the two numbers that multiply to get 20, I want to multiply to equal 20 and add to equal a negative 9. So this is the key here. They have to add to equal a negative number, but when they multiply, they're positive. If they're adding to equal a negative and I multiply and they're positive, both of these have to be negative. So I could have negative 10 and negative 2. That's going to add to be a negative 12. I could have negative 5 and negative 4. Negative 5 plus negative 4, that adds to be a negative 9, which is what we wanted. So here are our two factors, x minus 5 and x minus 4 set equal to 0. So our two options, we could have x minus 5 equals 0. So if I added 5 to both sides, get x by itself, I would have x equals 5. Or if I had this one, x minus 4 set equal to 0, and add 4 on both sides, we would get x to equal 4. So here are the two zeros of a function. So when it's function notation, we call them the zeros of the function. When it's not in function notation, we would call it the roots of a polynomial. So one more quick example. Again, to find the zeros, you set it equal to 0. So this would be 0 equals x squared minus 4x plus 4. And then you factor it the same way. So to get x squared, you'd have x, and I have to multiply to get 4, add to be a positive, or multiply to be a positive and add to be a negative. So it has to equal a positive 4 when multiplying, a negative 4 when adding. So this would be negative 2 and negative 2 would add to equal negative 4. So in this case, notice both of these are the same. It's a perfect square factoring pattern. So when you solve each of these, you're only going to end up with one value for x because you have x to equal 2 for this one and then x to equal 2 for this one. So this one just has one answer. X is equal to 2. Okay, so for additional practice for this lesson, if you need more help, make sure you go to page 334 and 335. numbers 1 through 7, 15 to 19, and make sure to complete that quiz.